Is there anything else? I don't think so. So it's time for me to introduce our speaker, who is going to present on a subject that I really need when I'm studying French vocabulary, because it's amazing. Give a big applause.
Thanks for the intro. All right, everything seems to be mostly in order, except I have slides. Can I get slides? I see them on the monitor, but not on there yet. Can you see slides? Okay. Yeah, it's just like the talk name right now. Okay, so I'm going to talk about Anki, which some of you might know. It's a program which I use for remembering all sorts of things, and I found it really useful for like geeking out about making the spectrum of things that I'm interested in geeking out about much bigger. So like here's a couple of things which I can do with Anki, which I found useful. So I went back to my university education, and I went through a couple of these first-year lessons where you learn 50 theorems about analytical geometry or something, or let's say mathematical analysis, and now I can remember the proofs for them. I'm never going to again forget millimicron nanopicofemto atozepto yokto. Or you can remember 0118 999 88199 0119 7253 91 whatever. Yeah, I can recite my IBAN from memory. You can use it to memorize the NATO phonetic alphabet. When I went to Switzerland, I used it to learn German from basically knowing nothing to being at B1, B2 level in about a year. I use it to memorize people's names. So if I have a picture of you somewhere online, I basically assume that I have permission to put it into my Anki and to use that to remember your face and your name. I use it to remember keyboard shortcuts. Remember, when I read a paper, I use it to remember what the paper was about, what were the basic methods, other random things. I'm not at all a science person or medical science person, but I used it to memorize a bit about the human body, the names of major brain regions. So how Anki works. So Anki and spaced repetition in general works based on a thing called the spacing effect. Basically, the spacing effect has been studied since the beginning of the 20th century, and it's an effect where if you have 1 hour of time that you're willing to invest into learning something, then the thing that you absolutely do not want to do is spend 1 whole hour in one chunk learning the thing, because then you're going to put a lot of information into your head, and then you're going to forget it in 2 hours. Turns out that it's much better if you spend, say, 5 minutes studying it at first. Then you come back an hour later and you again study it for 5 minutes. Then you come again 2 hours later, then you come a day later, and so on. So that means that you can invest this time into learning much more efficiently. And the reason this works is that every time you're remembering the thing again, after a certain time has passed since you last recalled it, you have to think a little bit to remember it, because you don't have it immediately in your mind. And what you're doing there is thinking for maybe 5-10 seconds, what is the thing? And then you're doing active recall. And active recall is the thing which reinforces memories, which makes things go from short-term memory to longer-term memory. So spaced repetition is an algorithm, in a very simple sense, which uses this spacing effect to let you learn things fast. And the thing which you do is super simple. You just try to do something, some kind of skill or recalling something that you're trying to learn, and you just see whether you did it correctly. And if you did it correctly, you wait a bit longer until you try it again. If you didn't do it correctly, you do it again after a shorter interval. Basically, like it's typically it's done like exponentially. So like next interval either like is multiplied by a constant or divided by a constant. So Anki is a open source tool which is used to make these flashcards. So a flashcard is a thing where you have kind of a question, which in this case is like try to remember what is the integral of the logarithm of t dt, and then you try to remember the answer. You press show answer, and if you remembered it correctly, you then rate like how easy or hard it was for you to remember. And so this is just like a software implementation of this algorithm. Let's see. Right. So Anki has a lot of nice things. It's multi-platform. It's also on Android. It has a synchronization server, which is not open source, but there are a couple of open source ones. There's syntax highlighting. There's lots of pre-made cards, which for lots of subjects, especially people like medicine students who have to memorize a lot of stuff. They make a lot of cards. There's cards for every like major language. There are tags that you can add on your notes, and the cards that you create in Anki are HTML plus JavaScript. So you can script them. You can make them potentially interactive. And also, it has an active developer community. Here's a couple of examples of stuff that I like to do with Anki. This is one add-on, where this is an add-on which is useful for memorizing things which you can represent as images. So this is the map of all these annoying tiny islands in the Caribbean. And like, this is an SVG where there's the name of the island, and you can like overlap these things over it, and then like the opposite side of the card shows you the actual name of the thing. And this is useful especially for like anatomy, like whatever can be represented as an image, or like this is like some kind of a neural network thingy. It also supports LaTeX, so you can very nicely use it for mathematics, for like definitions, theorems. Also, I made a thing called permuted close, and I use it to memorize things which I confuse. So, for example, like I used to not be able to remember like what type of radiation is alpha, beta, gamma, and this is a card where every time you see the card, it will randomly permute these rows. So on every permutation, you will see a different order of them, and you have to remember which one is which. So like under this, the answer that this asks for is like that gamma radiation consists of photons, and beta consists of electrons or positrons, and alpha consists of helium nuclei. Or like I can use it to like memorize like which type of pasta is which is a very useful skill. Yes. So I've heard a lot of people use, at least like trying Anki, but some people have problems like actually putting it into practice. And there's a couple of tips which are good to follow. One of them is using these closed deletions. A closed deletion is a thing where you have some text and you remove a bit of the text and you ask to complete the middle. That's a very useful way to phrase these questions. Then it's good to treat your collection as like a work of love, to like refactor it, to like go through it, make sure that like everything is phrased like the optimal way, that like every card is asking for exactly one fact to recall and not like asking you to recall. Like you don't want to have a card where the front says Aristotle and the back says like 50 facts about Aristotle, because then if you see the word Aristotle, you can't recall all the 50 things at once. You want to have like 50 cards for each individual thing. It's also good when you're reviewing cards. It's good to notice where there are problems. Like if you're noticing, oh, I always keep confusing these two words, then it's good to notice that and like note it down in Anki, and later go over it and try to fix it in some fashion. Right, I talked about redundancy and atomicity, and Anki is really nice for like gamification purposes. Like it's a thing which I do in all of this like that time when I'm like waiting in a queue, standing in public transit, or like sitting on the toilet. And that means that like over a day, if I have a bad day, I might review maybe like 5 cards. If I have a good day, if I'm like flying on an airplane, if I have like 10 hours to spare, I will review maybe like 1,000 even. Here's a bunch of links. All of these links are in my slides, which are not linked here, but you can find them on the wiki. There's like a bunch of documentation, recommended plugins, and that's the end of the content. And I can also show you a demo. How much time do we have? Enough. Okay. Okay, so this is my Anki setup. This is like the main window, and if I click on all, I just it contains even like stuff that I don't want to necessarily show publicly, like people that I know who probably wouldn't want their faces to be public. But like here, let's see if I can make this a bit bigger. I'm gonna hope that you guys can see this. Like this is a card where it asks me to overwrite working copies README with the content of the README on the master branch. And here's the command line saying git question mark source master README MD. And this is asking me to remember the word restore. So I press space and it shows me the correct answer. And then I rate that I remember this like good, this was good. And then here I have a little bit of Python, like this is asking me for like date time, the date of 20, whatever, like the constructor, date time, days today actually, yeah. This is the thing which I like learned about like earlier on this camp, that there is a term called the process window. That's like a range of acceptable parameters for some process. Or like here I have some like random thing about stocks. This is the thing where like, you know the terms meteorite, meteor, meteoroid, asteroid. Like these all are subtly different. And just like yesterday, I added a card where I decided I want to remember which one is which. Or like I use it to memorize also like country flags. This is Armenia. This is I think Latvia. Yeah. Or like capitals. This is Tirana. This is Santiago. This is, I think, Venezuela. No, Colombia. 2016. This is like aliases for OMI-ZSH. This is super useful, especially for like getting better at using your computer, at using whatever tools you have, because often tools will have keyboard shortcuts, and it's good to memorize them because then you're like way faster. Okay, I think that's about like all the interesting stuff that I can show. Shall we have questions?
If there are any questions, there are mics in the path in the middle. No? Okay, then another big applause. So for the next speaker, I was a little confused at his subject because the title was How to Survive 100 Meters Underwater, and I was thinking about programming, but it's super cool. It's about scuba diving and how to survive it, and the technical aspects of it. So I can't wait to see what he's going to tell, and give a big applause.
Spinning ball of death, of course. So for the past few years, I've been scuba diving quite a bit. A few years ago, I went on vacation to Thailand because my manager said, okay, you really need to have some vacation. And I was working too much. And after I booked everything like a few weeks before, I thought, okay, what am I actually going to do there? And yeah, I happened to go scuba diving and I got addicted. Now, just before COVID, I decided let's spend a lot of money and buy some technical diving gear. Because if you've ever scuba dived, then you got your certification from PADI, SSI, or one of the other certifications. And in that standard course, which is usually a few days, you learn, okay, don't go deeper than 30 meters because that's dangerous, and you don't know how to deal with it, etc. So everything beyond that is pretty much called technical diving, and that is what I've been doing for the past few years. Now, and it seems that a lot of people that dive have some relation to IT, and I was talking to some people around here, and I was like, okay, I made a cool dive last March in Thailand. I did a dive in a cave to 100-meter depth. It's called the Songhong Cave. These are some photos here with me and the equipment that I went down with. I'm not sure if you still see something, but OK. So what you see here is what the bottles or the tanks that I had on my back, and additional tanks that you need for decompression and such. So to be perfectly clear, right, I'm not a scuba instructor. I don't have the intention to ever becoming one because I don't really like that part of the diving, and it's too commercial for my taste. But don't try this at home. I assume that you don't have a 100-meter deep pool, but seriously, if you'd like to do this, very cool. I'd be happy to give some tips, but you do need your training and your certifications and such. Plus, if you do any certifications or theory around it, the first line is, OK, this is dangerous. You take a lot of risks. Know what you're getting yourself into. Now, this is a log, what you can see, where I did the dive. So I'm not sure if you can read the details, but it took me about 25 minutes to go down, because in a cave, in that case, you don't go straight down because there's actually rock beneath you. And it took me about 25 minutes to get to 100 meter. Now, I could spend very long time there, 2 minutes, and then I had to go back up. So it took me 25 minutes to go down to 100 meter. I spent there 2 minutes looking at people that put all their tags on the line, showing, hey, I've been here. And then we went back up. And I had over 90 minutes of decompression. Now, if you're not familiar with scuba diving and what the hell decompression is, so if you do these deep dives, you breathe air. And if you breathe air here, we breathe about 21% oxygen and 79% nitrogen and some other little gases, but that's about it. If you go underwater, the pressure increases and the molecules get closer to each other, and you basically breathe more of that same gas. Now, with oxygen, that is not necessarily a problem because your body takes care of it, and that's fine. The problem here is with nitrogen, or if you go very deeper, you add some helium. That gets into your tissues, and under heavy pressure, that's kind of OK. But if you go back up, it expands. Now, what you want to prevent there is that there will become bubbles in your tissues, because those bubbles can get in between nerves and in your back, in your spine. You can get paralyzed, or you can even die in the worst case scenario. Now, the other problem is, what kind of gases do you actually breathe? So I made a list of how it would look like if I would go down with the same mixture of gases that we breathe here. Now, you have something called a partial pressure, and together you see that is 100%. So that doubles, or at 10 meters, that doubles and then increases at same steps every 10 meters. Now, there are two problems here. One is, at some point, you get narcotic, and that is because of the nitrogen. And that gives you a happy feeling, maybe even stoned, which is cool, but not so cool if you're 100 meters underwater and you don't know what to do anymore. So what you do to prevent that is that you replace part of the nitrogen by helium, which is a lighter gas and doesn't cause those same effects. It does have other effects, such as a very high voice, which is kind of cool, but it has benefits for that as well. The downside of helium is that it's crazy expensive. So if you are like, OK, I want to do that technical diving, make sure you bring a fat wallet because it's very expensive. To give you some insight, for these dives that I made in Thailand, there were 3 deep dives. It costed me about €1,000 of gases alone. So, and that's apart from everything else. Now, the other problem is the oxygen. At some point, oxygen gets poisonous, and we typically indicate that on the partial pressure of the oxygen. And in diving in general, the partial pressure of 1.4, that is the limit that you go to, or that you can have. And that means that at 1.4, you don't get convulsions yet. But anything higher, if you have a high workload, so if you're swimming, if you're doing stuff, it could happen. And getting convulsions here and dropping on the floor, kind of okay, we can handle that. If you black out underwater and you stop breathing or whatever, yeah, that's not so cool anymore. So what you do for these deep dives is that you actually decrease the oxygen. Because what you do is, say on these deep dives, what I did, I had 13% of oxygen. And that means that I can't breathe with here. Yeah, you can take 1 or 2 breaths, but at some point you will pass out. You won't die immediately, but that also means that you can only breathe it when the PO2 gets high enough for your brain and the oxygen to be processed. So, that means that you have to carefully plan everything when you're going down on such a trip. Now, there are great tools for doing that. Subsurface is one of them. It's an open source tool. It was originally designed by Linus Torvalds, who also was or is a scuba diver. Yeah, so what I did here, I made a quick example how I would plan a dive to 100 meter. So what you are seeing here is that I'm having a double 12, as they call it, which means that there are 2 tanks on your back, 12 liter. And I have 3 additional tanks with decompression gases, because you want, on your way back, all that gas is still in your tissues. You want to increase the oxygen at a proper depth to make sure that you breathe less of the inert gases, like helium and nitrogen, and to make sure that it goes out of your tissues, and then at some point you can surface. What you see here, for example, if people can read it, is that I go down on my 50% oxygen. Now, I do that for the reason is that on the surface, I cannot actually breathe the mix that I had in my back tanks. I only had 13% of oxygen. So at some point, I switch to what I have in my gas, and then I can go deeper. Now, at that point, I am at 100 meters, and then I can go up. Now, how do I decide when I want to go back up? So if you are diving in caves or doing deep technical dives, there's the golden rule of the 1/3 of gas. So the idea is that in your planning, you always assume that you want to surface with 1/3 of your gas. Because if something goes wrong, that means that you still have sufficient gas left to come back to the surface. So in your entire planning, you basically do that. Now, there's one other switch that you see a bit later on when I go up. That is actually also with helium combined. And there's something called isobaric counterdiffusion. I have no idea who came up with the term, but if you switch very quickly to between helium and nitrogen, there could be side effects. You can get dizzy and whatnot, and what I said earlier, if you get dizzy here, that's all okay. Being that underwater, not such a good idea. What you see in the rest of the planning, at some point I go to 50%. That's typically at 21 meters depth. And then at 6 meters depth, you switch to 100% oxygen, which means that at that 6 meters, you are at PO2 of 1.6. And you might think earlier, didn't you say like, okay, you have a maximum of 1.4? That is correct, but the exception is for decompression, where the assumption is you are pretty much still in the water. So you don't have much activity, no high workload. And as you can see, after much time of being still in the water, you can finally surface. So yeah, pretty much that is how you could survive. But as I said at the beginning, a lot of planning, training, exercise comes into that. So yeah, that's pretty much it.
So obviously you can ask questions, but I had a question as well. So how long does a dive like this typically take?
So that depends on the decompression, but in this case, the one that I did was just over 2.5 hours.
Wow, okay. That's amazing. Are there any other people who have any questions? No? Okay, well, again, a big applause. The next speaker, he introduced himself and I asked what he was going to talk about and he said mosaic. And I was like, wow, that's amazing. Stones, that's something, I'm not a programmer, I can understand. And it was software. But that actually made me more excited because now I can learn about something I had no idea about. So I'm here to introduce you to Pepijn and he's going to tell you about mosaic.
I borrowed Thomas' laptop and I'm not sure how to plug it in. It's I don't know. It's his laptop. The guy with the beard there.
Oh.
It's.
Night.
I can use any random laptop that has a web browser, but.
This.
This one or the other one? No. I don't know. Maybe. Or does I need press harder? Yeah. Okay. Oh, yeah, it's doing something. But it changed the screen resolution, so it detected it at least.
Yeah, but somehow it didn't do
No. Does anyone have a laptop with HDMI that they can borrow? A laptop with HDMI. I kind of wanted to show the thing. Like I can use any laptop with like a web browser and HDMI. I mean, I can just tell about it, but it's kind of boring.
Yeah. Okay.
Maybe.
Test. There's someone? No. Okay, so there are a couple people solving the issue.
Maybe
That's a great idea. So we're going to swap around some things. So the next speaker, let's see, is Richard, and he is going to tell about a subject I think is so cool. It's called a Furby. Who here has heard of a Furby? Whew, me too. I had one when I was a little bit smaller, and then my little brother dropped it off the stairs, so it broke down. But my dad, he actually opened it up, so he took all the skin off and looked at the mechanics. For him, it was cool. For me, nightmare material. But Richard here is going to tell you a lot about his Furby and all the cool things that it can do. So give a big applause for Richard.
Okay, I don't have a mic. I don't have a mic, but I'm going to talk about Furby, and I have to improvise too because there's a quick change in speaker slides. Can you hold the mic? Okay. And do we have a stage for my co-speaker, Furby? Can you grab a chair for me? Thank you. Okay. And I'm going to share a presentation. And so actually, I'm going to talk a bit about what I'm doing here. I'm talking about Furby. Oops. Is the screen sharing? There it is. Yeah. Okay, cool. So I have Furby here, and I'm going to put him on the chair because he's very important. Oh, that doesn't work. All right. I'm afraid if you can't see it that well, if they do demo, we'll figure it out later. So I'm talking about Furby. Furby is a 90s tool that can talk and speak. You might remember it, but I'm going to upgrade it. Why does it not click? Okay, so we have the old school Furby. The old school Furby had very limited commands. It just had a few commands. It could do, say, a few words. It could do a few movements. It's very basic. There have been newer Furbies since the 90s, but I really like this one because it's the one I used to have. And I'm trying to upgrade it with a bit more intelligence. So the goal is that I'm going to have a real live pet. It can talk, it can walk, it can maybe sing for me, and I can talk to it. It will talk back. It can control the house. It can have expressions because it already has a motor in there for doing that. But the problem is it also has to be fully private, so I can run it at my home without exposing any data to the cloud or to Google or to the Amazon people. So I'm going to talk about how the Furby works. So there's a really nice patent that's online. It will show you all the details on how the internal components are, which help me to create this presentation. In the Furby, we have a speaker, we have fur, and I'm going to talk about the details here. In here, in the Furby, there will be a motor that has a worm wheel that drives a little cog that controls all the components with one motor. So the eyes, the ears, the mouth, it's all connected to one engine. So I'm going to see how I can make this all work. I'm going to put a Raspberry Pi in there. It's 0W, works pretty well. It fits inside. It has powerful enough to run on a Docker container, and then can maybe use it as a wake word trigger or relay speech to text to another server. If you want to see these components, I listed them here. I also have it all on GitHub. So to make space for the Raspberry Pi, I removed a little piece on the bottom. So I cut it off with a cell very gently. And now it fits really well with Raspberry Pi and a speaker head. So now it can do some dancing. So yeah, so there's some music, and I wanted to share the music. So it's now dancing, but this is one motor. The motor is continuously spinning, which is beautiful, and it looks cool, but I really want to have control of one single expression. I want to say eyes open, mouth closed, ears up, ears down. So to do this, there. So we have a positioning of components inside the Furby. In the Furby, there's a wheel. The wheel is what I'm talking about earlier. It's driven by the motor. It has a little wheel that is connected to a slide, and the position of the hook from the eyes is in one slide. Then there's another wheel for another gear, another part, and the pin will slide through the wheel, and the position of the wheel will tell how the eyes will look. To do this, we have a little wheel here. This wheel turns. There's a little gap in the wheel. And when we have a light sensor in here, it's positioned right here on the bottom. There's a light, and then there's a sensor. The wheel turns, and then there's a gap in the wheel right there, that every time the light is shining through the wheel, we can count it as a pulse. And by this, we can very accurately position all the engine parts and all the the expressions and body parts with this one wheel. So these are all the settings that I have. But to demonstrate it, I brought my Furby, but I think I'm going to do a video here. I'm going to start here by doing the calibration sequence. I'm turning the wheel full clock cycle to know when it hits the button, because every time the wheel makes one full turn, it presses a button. Now it says calibrated. The Furby is now ready to go, so it starts at like, I press it down, ears up, ears down. So I'm still trying to make a combination of the expressions in here. I can say, okay, I want you now to sing a happy song for me, and it will go do that expression. Or it will look disappointed at me, or it will be bored. So now demonstrating every sequence of this wheel. So it's going. As you can see, I can really have full control of where it stops and where it goes. Yeah, it's really happy to see it. Now, the Furby clock works as follows. If the eyes are, let's say, open and ears are high, and I want to go to here, I first have to go through all these steps. But I can probably toggle somewhere with an expression here in between, or an expression in between here. This way, I can really make an expression that's a complete set. But like I said before, the whole thing should be private. So there's implementations of Alexa that you can install on your Pi, and you can relay your whole house to Alexa, but this is too easy and I don't want to do that. So I use Raspy, which is an open source Alexa program. You can configure it and run it on the Furby, connect it to MQTT. We do the same thing on the biggest server I have at home. We have PDP-11, and we connect it to Home Assistant, and then you can relay the MQTT commands to Home Assistant, and then control the Hue lights, and then the Hue lights consecutively. When you, for instance, walk into a room, the motion sensor triggers, it sends an MQTT event, then the MQTT event will publish a REST call to the Furby to make an expression, and to also do some text-to-speech. So, this is how that works. I need to get some breath. Okay. With Raspy, you can do custom wake word detection. That means that if I now say, hey Furby, it will tell me hi back. So, hey Furby. I don't know if you heard that, but Furby was singing yeah, da 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 when I said hey Furby. So with Raspy, you can make your own wake word setup. There's probably a tool that's not part of Raspy to do that. But it's really nice to set it up. Cool. Now, to configure Raspy, we have a few sentences. It's like, what time is it? Or tell me the time. You write the sentences down. This sentence then triggers an MQTT event that goes to Home Assistant. And then it also triggers the Furby to have a sort of like nice effect. So this is Home Assistant. If you don't have a Furby, it's still pretty cool to set it up. You can easily integrate it with everything in your house. It's open source. You can make shell scripts. You can put it all in a Git repository. You can easily deploy it and manage it. It's a really nice tool to play around with on the weekend. So the whole project is still work in progress. So I showed you now that I have gained full control on how the Furby looks. But I want to make this into a sequence of events that can combined make an expression. So with this expression, I can make a REST call and then connect the REST server to the MQTT server. And of course, we have the Furby here, but there's still plenty of room for a camera. So I can also add face recognition and image recognition, and then make it like a real animal that will be happy to see you, of course. The whole project kind of works now quite predictably. So it's not as nice as a cat. The cat will greet you or not. Maybe it will not greet you. The dog will or not. So for me, this is like quite boring. So it's only magic if you understand it. Somebody said this to somebody yesterday. I thought it was quite funny. So I want to add some randomness or some unpredictable or some intelligence that will be like surprising or nice to see. So it will become magic and like real pet. It is online. It is on GitHub. So you can look at the source. It's still very basic right now. So I still want to put all the slides that I made today because the whole idea came up yesterday. And I need to like document it. So like when you look through the code, you can still like look at all the references and make sense of it. That's my email address. And if you have other ideas, please come talk to me. And I'd love to add more to this project or share it with you. Thank you.
Well, thank you, Richard. That was amazing. I learned so much. If anyone has any questions, again, there are mics in the middle, or you could email or, well, just ask.
Cool.
So thank you.
Thank you.
And then for the next speaker.
You wanted to share your slides on here, right? Okay. I have to show. Where is it?
So are you going to go last? Okay, so a little bit of change of plans. Just to let you know, there are 2 more talks. So in the program, there was only 1, but now there are going to be 2 more talks. You can go last, if that's okay with you. Does it work?
Is it? Oh, sorry, I have to change my keyboard layout. There we go.
So our next talk, I already introduced. It's about Mosaic, and now the laptop works, which is amazing. And he's going to talk about, like I said, Mosaic. So another applause. And then he can start.
Can I like do it full screen?
The website?
Yeah.
Yeah, sure. And then you want to look at README?
No, I just the website here.
Oh.
Gronk. Okay, let's give it another try. I'm Pepijn, and yeah, I'm originally a software developer, and then I studied electrical engineering and IC design. And then I figured that actually the software that IC designers use is kind of not so great. So I decided to write open source software for IC designers. So this project is basically that. It's a schematic editor for IC design. You can also use it for like simulating other stuff. So it's like basically a SPICE simulator interface. And I will talk a bit about it, but also what I want to do, I see a few people with laptops. One nice thing about this, or like different thing about this app, is that it's online and collaborative. So if people with laptops in their labs will go to nyancad with a D at the end, .github.io/mosaic, and then you can go to try online. We can actually edit the same schematic, and I will be able to see, hopefully, what people in the audience are drawing, which will be, I think, a funny experiment. This is the main, yeah, so this is the entry point of the application where you sort of manage your libraries and your models and your stuff. You see the little spinny thing in the corner. It means it's like downloading the database now, because it's by default it talks to a CouchDB database in the cloud. So yeah, it will synchronize your schematics there, but you can also use it offline. It's like an offline first web application. So if you like go in workspace properties and remove the synchronization URL, you have a purely offline application. You can also run your own CouchDB or whatever. And can I go to the previous tab while it's loading? Oh. Okay, I will just add an interface and see what happens. So let's design a filter or something. And add a schematic. I'm going to name it MCH filter. And now if I, like, in theory, this should eventually show up on your versions of the thing if you have a laptop in your lab. And if you double click it, you can open the editor. Yeah, this is the main editor. It's designed to be like very easy to use, but also quite powerful. So you can like everything has like, you know, mouse buttons that should be obvious, but you can also hide all the stuff and use keyboard shortcuts for everything. So I can like press R and then we'll place a resistor. Oh, it looks kind of a bit broken. Maybe the CSS is a bit not loaded. Anyway, hello? Help. How do I get back to... Like I'm... No, but that, like I did this like where it zoomed out of the window. And I'm not sure how I can get back into the... This is like an Apple thing. I'm just not like...
Also, because they had to talk to Furby.
Ah, okay, you're on a different network. Okay. Maybe it's now completely broken. Anyway, let's delete this one and place a voltage source and draw some wires and some more wires. Okay, it's quite difficult to do with one hand. Yeah, so that's the basic idea. It seems to, oh, and I'm scared to press escape now because when I pressed escape previously, it did something weird. Anyway, so next thing I can show, like I assume nobody has made it to this place yet because I don't see anyone else edit showing up. What I can try now is to run actually a simulation in the cloud. So what you would do is you can install this. Like so now it's running purely as a web application. But of course, if you want to run a simulation, you need to run some simulation somewhere. There's also a desktop installation, which is based on JupyterLab. But there's also this thing called MyBinder, which allows you to like turn a Docker repository or like a GitHub repository into a Docker image and then run it into the cloud. So, I mean, demo effect, this will probably not work, but it's technically should be, yeah, okay. Good luck. It should be possible to like launch instantly into a cloud environment where you can just like run a SPICE simulator that's open source to simulate your thing. But obviously not today. So, I mean, yeah, that's, I'm not sure what else I want to show. You can manage libraries, draw schematics, simulate them. But yeah, that's basically what I wanted to say is that like an easy-to-use interface for like, you know, clickety-click, just draw a schematic and run basic simulations. There's also like a notebook interface where you can like write Python code to run simulations for more advanced automation. And yeah, well here you can see a bit of the simulation interface, but it's a bit small. And of course nothing works, but anyway, I just wanted to show this, and if you're interested you can play around or ask me about it or whatever. That's all I have, I guess.
Too bad that there are so many Wi-Fi issues. Mine has been overloaded all day. It's like you try to load one Wikipedia page and the thing has a seizure. I can say that because I have epilepsy. If there are any questions, again, mics are in the middle, but I think they can also just approach you.
Yeah.
And don't be afraid to check it out. I think you could just play around with it. And
yeah, it's on GitHub. It's like nyancat.github.io/mosaic, and you can check it out.
So if I want to try this out, what should I Google? Or
like Nyancat Mosaic.
okay. Well, thank you so much. Then our next speaker is going to speak about a subject that I, as the younger generation, although it's maybe bad to say that, are going to have a lot of problems with, which is climate change. But not only are we going to have problems with it in the future, we are already experiencing so many issues. So the next talk is going to be about how we should take action now.
Thank you. Hello. Thank you. My name is MDB. Also in my dreams, I was calling myself Daya, or Daya in English with 5 letters. And formerly I dreamed about dreaming together with other people. I dreamed about the World Trade Center as well, like driving one 2-seater into the World Trade Center, and others dreamed this into a big airplane, and that was a mess in my dreams. So, okay. I also dreamed about climate catastrophes happening, which are already happening now. And I did refuse to think about or imagine what could go worse in the sense that, in the hope that with knowing what is coming towards us, told by scientists, the people, especially the people in power, would change their courses, the course of humanity, to the better and avoid such things. But it's all rigged. We have a monetary system that is driving even more money to money and totally forgetting about the environment. Everyone can rethink about 2021, and I think everyone has memories of catastrophes happening globally at least twice a week, and this was not the case years ago or decades ago. We are now having temperatures rising very much, more and more, and net zero and stay of CO2 in the air, in the atmosphere, is based on sinks available, like Amazon forest, like the Great Barrier Reef all around the continent of Australia, and also the plankton in the top layers of the seas, of the oceans. We all know Amazon forest has been reduced very much. The reefs are dying and are mostly dead meanwhile, and by diffusion of CO2 into the top layers of the oceans, in the top sea surface, that surface where the plankton is living is becoming a bubble water with H2CO3 with an acid, with acid becoming more and more acidic, and this will lead to the plankton dying as well. So the sinks for the CO2 in the atmosphere are partially gone, and some of them are going right now. And the CO2 that is now 421 micro parts, right, 421 ppm, will even raise. Some of it is not yet in the upper layers of the atmosphere where it's doing the worst effects, heating up our planet. And so what we have now, like in 2021, will be our future for at least 20 years. Same as 2021, at least 20 years. And with inaction and letting our rulers proceed to ruin everything. Sorry. This will be so worse. I mean, I can imagine the floors in Brandenburg around Berlin are getting deserts. This means the soil has the earth is gone, and it's mostly sand left over in Brandenburg, around Berlin, where the big droughts for the last few years have been. And I imagine, like, we will have lots of winds, not only heat points like now, still winds, but also heavy winds, because these temperature differences need to be ausgeglichen, equalized, right? They equalize each other, and so the winds will get stronger. Also, with higher temperatures, I was told that every degree Celsius gives the air 7% more storage of water capacity. So there will be stronger and heavier wind, so to say. It's probably hard to understand, but winds will get stronger, and we will have, like in 5 years, we will have probably within action, at least within action, we will have every day at least one tornado in every country in Europe. And it can be typhoons or tornadoes, and as the soil is mostly sand, there will be lots of sand, so we get sandstorms. And this is terrific, not only for the living beings, but also for the solar panels that are heavily damaged by sandstorms. And of course, it's not good for wind turbines as well. So we will have lots and lots of trouble, which is not being seen by our rulers. Our rulers are ignoring the IPCC assessment report 6 currently, which is, with the management report, very, very bad, despite the fact that there's filtering from the single scientist at the bottom that has to take care what he's saying to the public for his external payments still coming in and him not losing jobs. For example, in Germany, most scientists have only limited for 2 years working agreements. So they are very much in danger of not being employed anymore if they lose their third external money sources. So they have to take care that they are not free to speak freely what they found out and what they think will happen and how it will be. In the second level of the IPCC, there's the group, same thing happening again. Then the area of subject or area of region, same thing happening again. And in the fourth level, there's the management report, which is talked with lobbies and governments, and every word is gone through and checked against if that is maybe not what the governments really want to hear, the public to hear. So, and still, if you look at these pages, it's about 200 to 300 pages with different parts of the management summary. If you go through this, you will see it's very, very bad to know this. And I make a bet. Chancellor, our German Chancellor did not read it. He did not order anyone to read it, and he has no one that has read it and telling him how bad it is. Even with government intervention and lobby intervention and everything I told you right now, which is just logically, I cannot prove it, but everyone knows how it is. It's the world we live in, and it's rigged. Maybe it would help to remove money globally, but this is one thing that cannot be done by single persons or whatever. So, and I think this will not be done by our rulers at all, but it would help a lot if you imagine a society for requirements. So everyone gets food, water, or drinks, whatever, shelter, and from time to time some fun, of course, not to spare it out. And everyone needs the stuff. He needs to do his work. Because we can't live with an exchange trade system, because this would not allow specialists to continue the work. And we need specialists for example, for plutonium to keep. We cannot keep this with hands. We need technology. We need to continue be able to using technology to contain the plutonium we have. 1,300 tons, 1.3 million kilograms, and 1 kilogram or 5 kilograms doesn't matter really. Equally distributed about the surface of the Earth would be enough to kill all life. And these 1,300 tons, 30 million kilograms, 13 gigagrams of plutonium are mostly of that isotope that has 24,000 years half-time, which means we have to keep it for another 430,000 years safe to get back to an amount that is not really that harmful, in theory. In practice, we have lots of pollutions via Wiederaufarbeitungsanlagen, remanufacturing, like Wiederaufarbeitungsanlagen. Again. And also by accidents like Chernobyl or in Japan, and lost bombs, of course, lost nuclear bombs, nuclear warheads. So we already have a kind of pollution that has to be removed sooner or later. And after the climate crisis, if we manage to go through this as a society, as a working society, as a fully capable society, next thing I think will be to collect the plutonium back from the Earth, to contain it and to treat it in a manner that has to be invented. Thank you very much.
Well, thank you on a talk that is a subject I personally find very important. Now again, there are marks at the path, so if anyone has any questions, please ask them, and I think you'll be approachable for questions afterwards as well.
Yes, sure.
Yes. So that were the lightning talks for today. A big applause for everyone who spoke, who helped organize them, and yourself for listening to all of them.